Hello and welcome. In this video, we'll take a look at quadratic inequalities, which are nothing but second degree polynomial inequalities. So before I go over the two examples that I have selected, I want to go over the process of solving a quadratic equation and compare it to the process of solving a quadratic inequality. Some of the steps will be the same, and it's always good to start learning a new way of doing things by first using what we know already. So let's get started. Here we have an equation x squared minus 7x equals 18, and here we have an inequality x squared minus 7x less than 18. As you notice, all the terms are the same in both the equation and the inequality, except for one fact that in the equation we have the equal sign, in the inequality we have less than sign. We could have chosen any inequality sign, but that's what I decided to go with in this case. So when you solve an equation, a quadratic equation, we want to take all the terms to one side of the equation and leave just 0 in the other. So I usually prefer to have all the terms to the left side. So x squared minus 7x are already on the left side, nothing changes. But positive 18 will have to move over to the left, which makes positive 18 a negative 18. So that's what it's going to, this is what the equation will look like. Now, in an inequality, we do the exact same thing in the exact same way. So if we have a quadratic inequality and any polynomial inequality for that matter, we want all the terms to go to one side of the inequality and just leave 0 to the other side. So far, the first step is the same for both of them. In the next step, when we solve an equation, we try to simplify if possible, but in this case, we are already good because we can't simplify any further. And then we start solving. The most common method of solving inequalities will be factoring. So what we're going to do is we're going to use the factoring method for the equation so we can compare it to for solving inequalities as well. So the factored form of this equation will be x minus 9, x plus 2. So negative 9 and positive 2 will add to negative 7 and multiply to negative 18. So we do the exact same thing to inequalities. So x minus 9, x plus 2 is less than 0. So the next step to solving the equation is finding the roots, and we're going to say that the product of these two factors will equal 0 if either one equals 0. So we're going to say either x minus 1 equals 0 or x plus 2 equals 0. And from here, we derive the solution. So we're going to say x equals 9 for the first and x equals negative 2 for the second. And we'll say that both these two solutions will make the solutions to the equation. And this is when or where we stop to solving the equation. We're done. Now, when it comes to inequality, we still have to make each factor equal to 0. Remember that in an inequality, we are trying to figure out for what values of x would the product of these two factors be negative. Now, you can imagine how when we multiply two numbers, the product will be less than 0 or negative when they have opposite signs. So technically, the problem here becomes the problem of finding the signs or the values of x that determine the sign of the each factor. So when each factor is positive or negative. And in order to determine when each factor is negative or positive, we got to start from the 0. So what value of x will make the factor equal to 0. Because once we know when the factor or when an expression is 0, then we can figure out when it's positive or negative, because 0 is the number that separates the positives from the negatives. So this is the reason why we want to find the zeros of each factor. And the zeros of each factor here are 9 and I don't know why I did that. Sorry about it. And -2. And this is when the story changes from this point on when it comes to solving inequalities. And we'll continue here. So what do we do from here? So what do we do with the 2 zeros? Now, the next step will be building a chart. And that's again one way of solving the quadratic inequalities. And on this chart, you need to draw a horizontal line first, and then a vertical line right beside it. Now, the horizontal line from here to here will represent the values of x from -infinity to +infinity. And then on this number line, we are going to place the 2 zeros, so the zeros of each factor, and we must place them equidistant from each other. So we don't really need to scale this, we just need to write the numbers in order. So -2 is to the left, 9 is to the further right. Now in the column that we have created in here, we are going to list the factors of our inequalities. So x plus 2 and x minus 9. And here I'm going to draw a nice straight line. And right at the bottom, I'm going to write the product. So x plus 2, x minus 9. So what we are practically doing here is we are discussing the sign of x plus 2, the sign of x minus 9, and the sign of the product x plus 2 times x minus 9. So we're going to get started with the first factor, x plus 2. And we'll say that x plus 2 will be 0 when x equals -2. And if x plus 2 equals 0, like this one equals 0, 0 times anything will equal 0. So that will make the product also 0. So we'll write 0 here for the product. And then we're going to say that for values of x to the left of -2, and think about what numbers can be to the left of -2. So -3, -4, -5, -infinity. So for values of x to the left of -2, -3 plus 2, -4 plus 2, x plus 2 will have a negative sign. And for values of x greater than -2, so imagine -3, I mean -1, 0, 1, 2, 3, and so on. So for example, -1 plus 2, 0 plus 2, 9 plus 2, 100 plus 2. So the value of x plus 2 will be positive. So I'm going to write positive in here. And for bigger than 9, positive. Now we're taking a look at x minus 9. We're going to say that x minus 9 will be 0 if x equals 9. For values of x bigger than 9, think about 10, 11, 12. So we have 10 minus 9, 11 minus 9, 100 minus 9. So x minus 9 will be positive. And for values of x less than 9, think 8, 7, 6, -2, -300. So negative 8, let's say minus 9, negative 5 minus 9, negative 0 minus 9, negative. So all the numbers to the left of 9 will give x minus 9 a negative value. And now we're thinking, how about, oh, by the way, similar to this, if x minus 9 is 0, then we'll have x minus 9, which is 0 times x plus 2, any number will give 0. Okay? So now we're thinking, how about the sign for other values of x other than the zeros? Remember that for these values of x in here, x plus 2 will be negative and x minus 9 will also be negative. So the product x plus 2 times x minus 9 will be the product of two negative numbers. And two negative numbers multiply to give a positive. So we're going to say that the product will be positive here. Now, for the values of x between negative 2 and 9, so from negative 2 to 9, now imagine 0, all the numbers in between, right? X plus 2 will be positive, but x minus 9 will be negative. So the product x plus 2, x minus 9 will be the product of a positive with a negative. And a positive times a negative will give a negative. So we'll say that we'll have a negative sign here. And last but not least, for all the x values between 9 and infinity, we have positive values for x plus 2, positive values for x minus 9, so the product will be positive. So we'll say that the product here is positive. So now we are thinking, okay, so we did the chart. It was a little bit of work, I must admit, but what happens next? So what we are trying to find is when this product will be less than 0. So the product was less than 0 right here, negative. And the product became 0 for the x values between negative 2 and 9. So we'll say that all the x values between negative 2 and 9 will make the product negative. Now remember that we do not want the product to be 0, which means we do not want x to be negative 2 or 9. So therefore, we're going to say that x has to be, or take the values from the interval between negative 2 and 9, but not negative 2 and 9. And this will be the solution to this inequality. And with this, you're done. Now, what does that mean graphically? So we're going to graph this equation on decimals, and hopefully we can make a little bit more sense in there. So we said that we have x plus 2, x minus 9. Okay, so there goes our graph here. For the values of x between negative 2 and positive 9, you can see that the values of y, so here are the values of x, 8.6, 7, 6, all the y values are negative, right, on the graph. All the y values are negative. Then they stop being negative right at the intercept when it becomes 0, right? And then they start becoming positive, right? The y values start becoming positive above the x-axis. So we are going to say that the product will be negative for the values of x between -2 and +9. That's when all the values of y were negative, okay? So that's a graphical explanation or representation of it. So let's try to practice whatever we learned in the following example. So this time we have x minus 3 times x plus 2 less than 0. And we're going to say that first things first, bring all the terms to one side. Oops, they're already there. Factor. It's already factored for us. Isn't that nice? And now we're going to find the zeros. So the zeros of each factor, I'm going to show the steps better, are found by making each of them 0. So x equals 3 or -2. And now we are going to create our chart. Let me cheat here by using the option of drawing the straight line. And here goes the vertical line. And we're going to say that we have the factors x minus 3 and x plus 2. And here goes the number line from -infinity to +infinity. And the zeros are listed here in order -2 and +3. And we're going to draw a line at the bottom. And here we're going to list the factors or the product x minus 3, x plus 2. So remember that we are using the chart to study the signs of the factors and then the product. Okay? And we're going to say that x minus 3 will be 0 at x equals 3. That will make the whole product 0 because 0 times anything equals 0. X plus 2, on the other hand, will be 0 at -2. And that will make the whole product 0. So we can list the zeros first or mark the zeros. And now we're thinking about, or we're looking at x minus 3. That's where the 0 is. For numbers bigger than 3, we're going to say that bigger than 3, we're going to say that x minus 3 will be positive. Why is that? If you look at it from a different perspective, actually, and I'm going to quickly draw the graph of x minus 3. So the graph of x minus 3 will be this, slope of 1, y-intercept of -3. Okay, I knew this was going to happen. Okay, and we're going to say that if this is the 0 at +3, okay, that's because the slope is 1, right? So the y values will be positive above the x-axis, wherever the line is above the x-axis. So for all the values of x higher than 3. And it will be negative for all the values of x to the left of 3. Okay, so this is y positive and this is y negative. So whenever the slope is positive, when you go to the right of 0, you will have positive values of y, to the left, negative values of y. And we're going to say that 3 to infinity, x minus 3 will be positive. Now, less than 3, negative. And you can also take testing values in this case as well, right? So take a value of 4, for example, substitute it. That will give you a positive 4 minus 3. Take a value of, say, -100, substitute it. That will give a negative. X plus 2, on the other hand, is 0 at -2. For numbers bigger than -2, so let's say -1 or 0 or 500, this will be positive. So we'll say positive to the right of negative 2. To the left of negative 2 will be negative. So take as an example, negative 3. Negative 3 plus 2, negative. Negative 100 plus 2, negative. And now we're going to find the sign of the product. So we have negative times negative, positive. Negative times positive, negative. Positive times positive, positive. So we'll say that the product will be positive for the values of x between negative 2 and negative infinity to negative 2. It will be negative for the values between negative 2 and 3. And it will be positive for the values of x from 3 to infinity. So since we want the product to be negative, then we'll say that the product is negative for the values of x between negative 2 and 3. So we'll say x belongs to the interval negative 2 to 3, and thank you very much, but we don't want the zeros, so we're going to write round brackets around it, and we'll say that this is a solution to this inequality. Okay, so I have one more example, which is, listed here, which is pretty much the same as the one that we just did and the other one from before. And I would really want you to try this on your own right after we finish right after you finish listening to this video. And I hope again that everything made sense so far, and I hope you enjoy solving inequalities.